Hello guys, welcome. Good morning. I hope you don't mind the cameras moving because I'm holding it in one hand. Oh, I just woke up here. I'll show you. That's the bed I slept on right there. These are the things I'm going to use to show you some experiments. And this is where I slept. This is my tablet over there, the book, and power bank and all the stuff, My lead, my watch, my other thing, earbuds, neckband, right? It's a lens. Anyway, it's quite a mix-up, and it's a bit of confusion, this morning. As you can see, everything is gathered around, but I'm trying to see whether we can have something today together about what you regularly see in these things. But today I want to show you something quite different and amazing. This one, I'm going to show you what this is, right? Yeah, okay. And there is a computer there. I don't know whether you can see it. Let me just bend this like this. Yeah, when I put it like this, I think you can't see me properly. Lighting system here is quite poor. Actually, it's where I'm sleeping. I'm doing this video from. Can you see me clearly? Okay. Welcome, guys. I go by the name Victor Oya on YouTube, and today I'm going to show you how Arduino. So far we've been doing outputs. Today we are going to do input from the Arduino. So the analog, which I told you is continuous, we are going to see how it does this. Now the problem is that I have to keep moving this camera, right? There are a lot of technical terms here. First of all, let's connect this thing. This is a breadboard, and as you can see, I've connected two wires there. One 450. Unfortunately, these are the wires that I have. I mean the resistors, sorry. I'm calling them wires. There are two. One is 450, another one is 250. I've been using this because that's what is available. Otherwise, I'm supposed to use around 350 and 100 ohm resistor, but I don't have those. So we adjust with what we have, okay? Yeah, guys, so this is what I've done. So I'm going to hook up this Arduino over there, the computer, and we are going to read analog inputs, right, from this Arduino. This is a microcontroller Atmega 328. As you can see, this is a cable which I've attached to this. So let's start. Yeah, it's quite a long thing. There's a lot of maths involved, so I don't know whether we can be able to do that much because the place here is not big enough for me to do this. And let me see, guys, I'm risking because this table here, oh shit, let me see whether it's possible. Lighting is too poor. Don't mind about the clothes back there. It's like a wardrobe over there, that drum there for the church, right? That's a fridge and other things. It's not a room tour. You're not doing a room tour. So I'm going to do this. I'm going to connect these wires, and I don't know what I'll show you after I've connected them, because I'm only having two hands, and I hope this table is not going to collapse. It's quite unstable, guys. I don't know whether I should put on some light. Yeah, because really it's not clear. I have light, but how to hold it is a problem. It has gone off actually. It's an having of a bad tiding. I thought it's charged. Shit, man. Sorry. Let me put these wires, then I'll show you exactly what I'm doing. I can't be able to show you right away, but after I put them here in the breadboard, just as I put that one, which will go to the 5 volts of the Arduino. Yeah, Arduino is right there. And then I'll put another one which will go to the ground. Yeah, I'm successful to put another one which will go to the pin that we are going to read the signals from. I'm sorry guys, you are not going to see my face, but I don't think you are interested in seeing my face. So I've tied the 3 wires, okay? And briefly I tell you what this is. You can see this wire where my finger is pointing there. This will go to the 5 volts from the Arduino, okay? And this one, this blue one, green one, will go to the pin that we are going to read from A0, A5, A4, A3, A2, like that, whichever that we're gonna, for convenience, which one we'll take. And now the red one, this one is gonna go to the ground in the Arduino, okay? So this is the way I've attached. That's a resistor, and that's another resistor. I don't know, I don't have the way to show you this. Can you see them? Can you see this wire? This one? This is 450 ohm resistor. And this resistor up here, I don't know how to turn it. This one. This is 250 ohm resistor. Okay. So there are two. Disconnected. They are not connected. There's a trench in between. This one. There's no connection in between. So I've pushed it, taken this wire from here, which connects to this side of the 450 resistor. Maybe I should take them off again so that you can see. Can you see, guys? Are you seeing the wires, the resistors? The blue one, the green one, and the red one, where they are connected there. Let me turn it this way, see which one is clearer, that you can be able to see. Now this one, you see, this leg of the resistor, this one pin will go to the 5 volts, and then across we have this side. Now it's between pin 10 and 15. Now pin 10, then your Arduino, whichever Arduino, your breadboard, whichever breadboard you have, one leg of the resistor is 450, or whichever you have 350, the better. So this one will attach here. I'm trying to demonstrate this, guys, so that you can see. But this breadboard, there are limitations here. I mean, I don't know how it will appear. So what I'm trying to explain is that the white wire, the one that is white, is going to the 5 volts of in the Arduino, and it is connected to this resistor here, this leg of the resistor, which is 450. If I can take it out, I don't know whether I'll be able to see. Now can you see? You see this? I'm talking of this resistor. Okay. Now I've attached this wire here. Can you see now? This leg of the resistor. This is a bit obstructing it, so you can't see. and then this one is going to, the other leg is going to pin 15, where I've attached this one, which will go to A, from where we are going to read the analog signals, and this one connects across this trench. There's no connection between these two, but this wire I've attached here, this jumper wire, this will go to the ground. I mean, I can, you see, you watch it carefully. I have attached it. I think here you can see clearly the view. You can see this. This is going to 5 volts. This is going to the pin from where we are going to read. Then there's that other resistor which is connected to this one across the trench, and the two are not linked to that point where up there, to this point up there. Let me point it, that one. Then I put a wire in front of it, and this wire will go to the ground of the Arduino. Now let me connect the Arduino. I think I've shown you clearly the breadboard, and you know the breadboard is connected upward like this, not across. So along the same line, the 5 openings are connected. Okay, so I'm taking the Arduino here. Let me connect, then I'll show you. Well, sometimes you're gonna, one hand is holding a camera. Just hold on, guys. Let me just use the lens to see what I'm actually doing. Digital, yeah. So this is where we're gonna attach one wire to the ground, and I have to count it, the 4th from the up. 1, 2, 3, 4. Up. I've done it right. Let me count again. 1, 2, 3, the 4th. Yeah, man. I can't even see when I'm wearing glasses, and I can't see. The openings are too small. Let me be sure. Yeah. One, two, three, 4. I think it's right. Yeah, and the other one I'll connect complete, then I'll show you, because I have only 2 hands, guys. You can understand, you know. Don't worry about the stuff behind. It's not part of the video. And no. This one is supposed to go to the ground. 2. 1, 2. It's supposed to go to the 5 volts. Sorry, not the ground. And this one is going to pin 4. I'm going to show you guys. Just hold on a minute. And this one is going to go to the ground, which I just confused you. 1, 2, 3, 4. Right? Now I've connected it. The green pin is going to A4 in the Arduino. The red pin is going to the ground, and the white pin is going to 5 volts in the Arduino. 5 volts analog side of the Arduino. Okay, so I've connected it. Now I'm going to attach to the computer. I'm doing everything I can to show you this video, guys. Oh man, it has come out. Shit. Oh man. Maybe I should transfer and go to the other side, but the lighting system there is too poor. You can't see anything. That's what I'm trying to show it to you from here today. 1 2 3 4. 1 2 3 4. I hope I'm put it in the right place. It just came out. Let me do one thing, guys. Let me move this camera. I don't know how to put this thing. This side of the laptop has no opening. It's a keyboard area. And oh man, again it is coming out. Let me just be careful. Right? Let me push it slowly. I'm putting the Arduino on the breadboard on the same side because of the paucity of space here. I don't know whether you will be even able to see it, but let's try. Anything is possible, you know. We try. Don't say it's not possible. I'm trying to attach this thing to the computer and we'll start programming it because I've already shown you the connections. It's crazy stuff here. Let me see. Yeah, is it okay now? I think it's okay the way it is. Yeah. Now I've shown you the Arduino. I've connected the Arduino. I'm going to turn the camera so that you can see the programming part. First of all, when you're doing this project, let me see whether this thing is on. Sometimes, you know, it goes off. I don't know why. Actually, it's off. Now it's coming on. Maybe it has not been charged, you know, for a while now. I do forget. Let me tie this part of the button on my shirt so that you can be able to, the audibility will be there. I'll be audible enough. You know, I have a sung voice sometimes. It doesn't really, people, my audience complain that I should just talk to the camera. I should talk like this. Now, let me turn the camera, guys. So you start. See, now the camera will be moving around, so please have nothing to do about it. I can't help it, so I'm going to take it. And I'm going to turn the camera just in the next one. Let's go. You see, apparently I have to stop it. I'm sorry, guys. This thing keeps jumping. I don't know, maybe because I'm moving the camera around. So I told you go to the file, go to the examples, go to the basics and bare minimum. I don't know whether it's always necessary to do this, but let me do it for now. I don't want to make mistakes, you know. So you see it's opening here, another one. I don't think it's necessary. We can do the first one, but let's do this way. There it has opened. I'm going to tools. My computer is slow. It's not a terabyte type. So there it is. We go to tools. And from tools, you go to the board. You can follow the cursor the way it's going. We go to Arduino Uno, up there where the cursor has gone. Okay, Arduino Uno, you click that one. Come back again. And go to the port. Port is port 3, COM3 port. You click it. Because you have to connect it. If you don't connect this, then you not get the result. Now from here, we'll start to program, and it's quite a long time. Maybe let's try this one. And I'm going to maybe do another video on this. Maybe I'm trying to make it clear for you to see something. And, about the camera, guys, I can't do anything but just to keep moving because I'm holding it with one hand. It's not actually a camera. I'm doing this on a smartphone. I have a limitation of space here, and even lighting is not so good. But you can see what I'm telling you. Yeah, man. So we are going to try to program this Arduino, which is busy blinking there. I've attached everything. So let's try and program it. I don't know, are you seeing what I'm doing? Let me write, I'll show you. So I'm going to declare a variable called int integer, int. There I've written int to read the pin. Okay, it's supposed to read the pin, so I'm going to write a read pin. P is, you write in capital. I'm showing you just now, a minute. Okay, you see the command I've written. I declared a variable int read pin, and I put the equal sign there, you can see. So I've attached pin A4. A4 is a pin that I've attached there, A4. So we are going to put semicolon and go next, move down as we start now the programming. Let's use a float value variable, because otherwise we're going to have trouble with integers, because integers sometimes will give you wrong results. Because let's use float or the voltage. I'm going to write the voltage is V2. Are you seeing it? Float V2 is equals to 0, because initially, that's why we are starting. You're giving the value, then we are gonna feed some values there and then read from there. Okay, it's an input, not an output. So you see equal sign there, put it very clearly. And then let's go down. I'm going to write everything, and yeah, let's focus. Let's go to the pin mode. Don't worry about this, I'll show you. Pin mode. I'm showing you in a minute, just in a minute. Okay, now the cursor is there. You see where the cursor is? There it says put your setup code here to run once. Below that I'm writing pin mode. Where it says put your setup code, that is not part of the code, it's just telling you what to do. So you're gonna, below that you're gonna put pin, M is capital, mode. Okay, you seen it? Pin mode. Now pin mode, you're going to read what? Put a parenthesis there, and then you write read the pin, because you're gonna read is from the Arduino, so you put read and comma there, input, because it's an input not an output, input. Okay, you seeing it? Read input, and then you're gonna put the semicolon there. Okay, then of course you're gonna set up a serial monitor. We're gonna read the values actually. So below the pin mode, you're going to set serial begin. Okay, serial, I'll show you, don't worry about the camera. I'm holding it with one hand, but I bring it close for you to see like that. I've written serial point begin. Now we're going to begin, and gonna put the baud rates there. So here we're gonna use the most common one, 9600. There are others you can put, but for today, this is the best, the convenient one is this one, which is used in most cases. So, done. Are you seeing what I've done there? Maybe I should just keep it like this. Are you seeing? Serial dot begin 9600. Okay. Baud rate. That's, I think, baud rate. Then we come down now to void loop, where it says put your main code here to run repeatedly. You can see that if you have opened your computer, you have come across that stuff, you know. Then I'm just trying to go down. I'm being careful here, guys, to give you the most accurate thing. Put your code here to run repeatedly. That's void loop. Where is written void loop. Now the cursor is there blinking, pin 11 there. So there we want to actually put something like, I think we're going to put a read val, because if we put v2 it is going to give a wrong result. So we're going to read val, which means you have to declare another variable called read val, yeah, and it's an int. But for now, let's write it first. Read val, read val value. I think that's a variable. You know, you can write anything. Computer will output what you input. I written read val. I don't know why it's putting this colon here, but I don't want to interfere with it yet. Read val equals to analog read, analog read. Don't worry about the camera because it has to keep moving, guys. You know, I'm holding, I don't have a cameraman, so here you see read val equal to analog read. And what is it going to read from? It's going to read the red pin where we have initialized there in the variable up there. If you are following, you know now what I'm talking about. Read pin declared up there. You know, let you see where my finger is pointing. Int read pin up there, A4. You are going to read from A4 there in the Arduino. And yeah, I don't want to move the camera around because this camera keeps going off. I've already shown you that part, which wire goes where, which jumper wire goes where. I've shown you. So now here we are. Let's be careful. If we keep moving this, then it will jump again. So I've written that, and then we'll put actually not this thing. I don't know, this computer is automatically putting this. Should be a semicolon. And then down below we're going to have now the v2. We are going to have v2. Now let's write it v2. Now v2 is equals to, we are going now to calculate the real value from the Arduino. We put the parentheses there, and we're going to, guys, we're going to use points because otherwise if we don't use it, going to give integer values, and the integer values will resolve to 0, so you'll be reading only zeros. For that reason, we have to give, the Arduino is like that, it will give you zeros if you put integer. So we put a float, since we did a float, and there we put 5 points, divide with 1024 or 1023 because we start to count from 0. Alright, then I explain to you. The code is there, you can see it. V2 is equal to 0.5, and this 1023 also you put a point behind it like that. then you'll be able to read accurately the values. Otherwise, if you don't put the decimal point, it will give you an integer, and an integer will not give you the answer you want, because here we're having float values. Okay, analog is continuous reading, in between values are coming. Now times read val, so you're gonna multiply times read val. Okay, read, oh, it's coming capital, sorry, I want it to be in small case, lowercase, read val. Okay, you see what I'm doing? V2 is equal to, parenthesis, you put 5.0 divided by 1023. What does this come from? 5 will be equal to 2 raised to power how many? Because this is, we are doing binary. So it's going to be either 255 or 1024, but we start counting from 0. That's why I put 1023 times read val, which I've declared up there. I have not declared it. Read val, yeah, it's somewhere here in void loop. Read val analog, you see, read red pin here, pin number 11. You follow the count up to 11, you'll see where I've written that command. And then below that we're gonna do serial.print v2. I'd as well go with this one. I think we're gonna do now serial.print. Okay, below this I'm gonna do serial.print. Okay, let's go down here, and then serial, as I written it in capital, serial dot print ln line, print line, and what is it going to print? V2, which already we have shown you, because that's where it's going to read from. Already is there. So sorry, I want to put the semicolon. Okay, and also read val, I never put the semicolon. Oh, this would, if I don't put this, it will not compile. So guys, sometimes when you are doing this, you forget some things. So now we reach this part. As I told you that read val v2 is equal to 5.0 divided by 5 over divided by 1023. This will give a real voltage, and this is printed out. That's value there. It's going to give you the real voltage, and it's going to be printed out. Where my finger is pointing is pin 11, read val. In Arduino 5 point and the 10 is, the point helps to not to confuse with the integers, because the integers will not give it. Now again, we have to delay. We can't just do it like this. We're going to delay it a bit so that you can see clearly what is going on. So you write delay, and then you declare a variable, because you are not going to use constants here. Like the pin is 500. We're gonna give the microsecond, how long it will delay. Oh, come on, I've written again all uppercase. delay time will be, I'm going to declare a variable because I don't want to use constants up there. 1 minute, let me write this. Delay time, I'm just declaring a variable here. Delay time, I've done delay time, and then put the same column. Then Otherwise I could put 500 because a delay 500 or 1000. 1000 is too much. Maybe delay 250, right? Let's delay 250. For example, I could put 250 here, for example, 500 or 1000 delay time. Or let's put like 400. I think it's good to put, 500, 500. So let's put like delay, okay, let's put it 450 delay time. Now that is a constant and it's not allowed because it's not a good practice to use this. So that's why I declared a variable. I call it the delay time. Then I'm gonna give its variable up there. So I've written it there. Then we go up where we declare a delay time up there, void setup. I'm talking void setup, guys. I don't know whether you are seeing. Let me put it this way. Okay, now the camera focus is there. There the cursor is going up to that point. Then press enter here to give space, and I'm going to write in int delay time, int delay time. I'll show you, don't worry about the camera. I'm gonna show you delay time. Oh man, now why is it coming capital? I put delay t and time. Delay time equals to, we'll say so, 450 milliseconds. Okay, and now I've given you the delay time. I never gave you I gave you v2, the float, and into read pin. I've not declared another variable, read val, which I have just shown you here. Read val here where my finger is pointing, that's pin 12. Read val, I've not declared read val. You can't see it anywhere, so it has to be declared. It's a variable. So we're going up again, and I'm going to slot it just below read pin. I want to slot it here, I press enter in the computer. Then read val is going to be an int. Then it's read val value. It's a primitive. It's a variable. It's a primitive which allocates the space memory of a computer for us to access what we want. But we are not going to allocate a value here because we are going to read this from the reader. So there I've given it. Let me put it on the camera. Focus. There it is. Int val up there in the void setup, up, totally up in the global side of this thing. Now you see I've declared int read pin, therefore int read val. I'm not given any value there. Float v2 is equal to 0. Int delay time, I've given 450 milliseconds. Okay, so we're done with that. I'm done with this. So now we are going to upload this stuff. Now you have to cross your fingers for me. I don't know whether it's gonna work. Here you see where the cursor is pointing. I click that point. Now let's see whether it will compile. Oh man, there is a problem. Exit status 1. What happened? Some problem is there. Oh, read what? Read, it's supposed to be read pin. I've just said read. Okay, I've written read pin. Yeah, it's supposed to be read pin input, right? And what else is there? Let's check again. We don't need these problems. When you are writing these things, sometimes read pin. Let's go again. We see whether it compile again. Therefore, taking my cursor up again there. I hit it again. Let's try again. You see, there's a problem. Now begin serial dot began. Oh, where I wrote this. Oh, yeah. Oh man, simple mistakes. You see, spelling mistake there. These things get very sensitive. See, I wrote began instead of begin. Okay, so let's check again. Float, read, int read val, int read pin, int delay time. Now I want to be very sure, guys, because this keeps like this, it's no good. Let's try again to run it again. There we go. Done. It has compiled. It has compiled, guys. So this is what I wanted, Look, it has compiled. Now we are going to read the values from the Arduino, right? Let's see, 1 minute. For that to happen, we have to hit the star thing there where the cursor is gone. You see where the cursor is? See this thing, this, there. You hit it there. Then you sit down here, watch the values uploading. It's writing down where you see the yellow below. It's saying uploading. I don't know, it's uploading for very long or some problem is there. Upload error. Exit status 1. I don't know what is this status 1 exit which is keeps saying. I think we'd rather check this code very carefully. And this int is really very far away. I think maybe that's the reason. No. Read pin. Read val. Okay. Int read pin. Int read val. It's all correct. Float v2. That's correct. Everything's fine. Int delay time. I've declared this 450. Maybe I should put it 500. Let me see. Let me put it for 500. I don't know why it's not compiling. Let's put it 500. Okay. Now void setup is there. Then you come to pin mode, read pin, comma, input. Now the devil thing is coming here. Shit, man. Sorry, guys. This thing keeps coming to this. Now it has spoiled the entire code. Oh, man. Where has it gone? Oh, man. The devil is active in this world. Now you see this thing comes off. It's just a shit. Now it has gone when the code, I don't know where the code is. Here it is. Now I was checking up this void loop. Void loop. Yeah, everything's fine there. Let's come down. Read file. Read val. Analog. Read pin. So V voltage, everything is fine there also. Serial dot print line V2, everything is fine there. Delay and then delay time. So I think this is okay. I don't know why it's not printing out this output serial monitor. Sketch compiling is done. done. It's writing done. So when I'm going to run these values, I don't know whether the pins are not properly connected. I think the pins are fine. I don't know why it's not compiling. Let's try again. Yeah, with that one. Oh. Yeah, it's printing out, guys. You see down there? See, success. It's printing the analog values there. Very accurate. 2.51, because depending on the type of resistor you use, it will give you the value. So I used not the really recommended one. I used 450 and 250, and that's what the analog read is giving there accurately. This is the value, input value we are getting from the Arduino. Come on, how can I put this? Can you see it there? Yeah, there. You see? 2.51, 2.51, 2.51. This is the value that we have gotten after doing this code up there. And the Arduino is there blinking, very busy. I've connected it there to the board, to the computer. I programmed the computer here, and we've gotten the result. Now that is the correct result. That's the real voltage, and which is now being printed out. This one. This is the real voltage that we are reading from the Arduino pin A4 here. This experiment is very successful. We have done it there. And now, I don't know whether there's anything else for me to show you. I've shown you exactly how to do it. And you can, I don't need to show you the diagram. I don't have a board. And even if I show you the book, it will not be of any use, Let me try. You see that diagram I've drawn? Resistor 1, resistor 2. Come on. Yeah. And 5 volts that I've given. Guys, when you give 0 volts, let me show you. What do you think 0 will give? Here, I've drawn some kind of chart here. 0 volt will give you 0. Okay? Read value will be 0. But if you give 5, then it will be 1023 because of the binary factor. 2 raised to power something. It will resolve to this. That's 2. Yeah, down here. To prove, you take the wire from the first and put it to the top of volts. Yeah, it's talking about the proof, but that will be very difficult to do it now. Let me explain what I'm explaining. 0 to this, and is given here in value. If you calculate this, is come to 1024, but you start counting from 0 to 1023. V is a read value, V2, read value, V2. I've given this, but this is not correct way. Read val, this one, V2, this one, but I've shown you why we can't do this, because when it's 0, it will give you 0 volts there. And this is smart now. When V2, when it's 1023 over this, to give you 5 volts. It's just a formula, the way you can calculate this. Yeah, guys, I'm trying to show you what is available here. And I did some kind of writing. Volts. The volts are a measure. What is a volt? You know what's a volt? For those who don't know, volts are a measure of voltage, and milliamps stands for milliamps. MA stands for milliamp, which is a measure of current. These two are related through the equation. That's the equation is P is equal to 1 times V. P is equal to 1 times P power. Yeah, where P is power, I is current, and V is voltage. Now, how to calculate the volts to milliamps? Example, the formula is milliamps equal to P divided by voltage times 1000. Milliamps is equal to 500 over 120 times 1000. That's how you calculate it. And then milliamps equal 4166.66. This is not a part of this, it's just details. Now it's something I told you about floating points. Numbers are often used to approximate analog and continuous values because they have greater resolution than integers. Floating point numbers can be as large as 3.4028235 E plus 38 and as low as minus 3.4028235E plus 38. They are stored as 32 bits. That's function. Okay, so I'm giving you details. Now this is just theory. I've done the practical with you. Serial 9600 is the baud rate of communication. Okay, you remember the value I've given you? Where is it? Here. Let me point it with my finger. Let me bring it close. Oh man, this camera problem. There. You see where my finger is pointing? 9600. Here. That one. That's a baud rate. It's called baud rate. Serial 9006 is the baud. That's PAUD, rate of communication, which starts serial communication. So I've written the commands here. You see serial.print, serial.begin here. We did this in the code here, serial.begin, and here again serial.print. So that's what this value does. Yeah, so that the Arduino can send out commands through USB cables. This one, it is going to send it to there. That thing that is blinking, the Atmega 328 Arduino, is going to send it through this cable, and we're going to read it here. And there we have read it here. You see these values? There. Focus. There, can you see the focus? 2.51. I'll bring this thing close here. 2.51, 2.51. Those are the values we have written. Okay, that's the Arduino. Send that to the this console of this laptop, and you have read it there. After uploading through that, we hit that star there. After doing the code, yeah, guys. And something about this diagram is that these R1. I'd shown you what R1 is, where the 5 volt come in, and R2, the one that is connected to the ground in between, is the voltage that we are trying to calculate. In between this, here. This is what we are calculating. The R1 I've shown you, and the R2. By the way, now I can't here in the breadboard. I've shown you the blue one with the ceramic blue top. That should be R1. And the one with the red like ceramic with the red wire attached, that should be R2. Now we are going to read the voltage in between here. The green pin, right? And the red one in between. And the diagram is showing you, and we are putting in 5 volts here. So flowing there. Okay, so I don't know whether there's anything else I should show you here. So I told you about int red pin, int read val. So now I've shown you everything. Float on the delay time, pin mode, serial.begin, and read val, I showed you that. V2 serial.print line and delay time. Everything I've shown you. And I told you why we put 0.5 and 0.1023 is because if you divide an integer against an integer, it will give you an integer, and the integers in Arduino are interpreted as 0, and then your reading will be wrong. Okay, that's why I put point like float. This will lead to your program not working, as it will give zeros. When you put a point, it makes a float point number, and that is read by Arduino. That's the way Arduino is made. So guys, I've done this thing, and you can take your computers and try to do it again. And once again, I'm showing you the code there. Let me just 1 minute. I'm very happy that we have gotten the result here where the cursor is pointing. And let me just make it clear. You see there, this is the values you have gotten, inputs from the Arduino, sending it to the computer, and the computer has printed them here. So let's go up. Now this is the code. Let me give you a few minutes. Let me put it very clear, and yeah, now see, you can copy it if you want, but it will take a lot of time. Int, float, int. The first is read pin, the second is int is read val, the third one is float, v2 is equal to 0, and then we have int delay time, which is 500. I given 500. You can give any value. You can give 1000 or 750 or 300, whichever you want to put. The void setup, we have put pin mode, and we put in parentheses read pin, and then input is an input, not an output now this time around, because we are reading from the Arduino. And then serial dot begin 9600, which is there. Then void loop. Oh, the battery is running out, guys. Sorry, my computer is gone. I did a silly mistake. I never put it. Oh, come on, do fast. Do fast. Oh man. My laptop, the backup of the battery is very poor. So, okay, I was showing you this. I just managed. And let me bring this one down. I'm really enjoying this. Even I don't want to stop it. See now? Look. Now, void loop. There. Read val is equal to analog. Read. We are reading read pin. The one we have declared an integer up there. A variable. Then v2, we have given the maths there. Okay. Just copy that way. Serial don't print line. v2. Delay time. There. It's quite clear. You can copy this and do it in your computers, and you'll find the result. I've told you the procedure. You have to have Arduino loaded in your computer. Then you go to install as file, examples, basics, bare minimum. It will give you, go to tools. You set the board, which in my case is Arduino Uno, whichever you are using. Then you go again, you set the port. I'm using COM3 here, and then you just write this code, and then you upload it with the arrow pointed to the right up there, this one. And then it will upload. Then you print out with the star, this one. This, you hit that button. I'm pointing to the mouse, guys. Don't point to the cursor. Come on, kienyeji. This one, okay. When you hit this one, then it will print for you these values, which the real values, which are being sent from that blinking stuff there. That's the Atmega 328 Arduino Uno. Very powerful thing. Okay. Can be configured to give anything, to do anything you want to do. That this experiment that we set up, and I showed you from the beginning how it runs. So that's it, guys, from me today. I don't know, you don't need to see my face because you saw it before. Yeah, catch up with you next time. Please subscribe to my channel, like and share this video. And it's a great work we have done today. Okay, bye from me. Bye from Victoria. Those are the names I use in YouTube. If you want to access my channel, you go to Victor Oya, and then you hit the subscribe button, guys. For me, I'm sweating bringing you this stuff, So just be kind enough to subscribe to my channel. We are just in the beginning. We are going to do a lot with this project, and if you follow it along, you end up making real stuff move with this Arduino Uno microcontroller. And it's only that I don't have some accessories which I need to use to run motors, to give sensors, to do things, to connect to your mobile, to connect to Wi-Fi. So that thing does a lot, as you see there. Anyway, bye from me today, and nice talking to you on YouTube. Now you're not seeing my face, I'm smiling. Bye guys, bye. I've not even had breakfast, guys. I thought I'd do this first. Bye. Please subscribe and like and share this video. It's a very nice video and very educative. For those who are doing electronic engineering or even computer engineering, this is a very useful video to you. Okay, bye.